Hello everyone, Shalom, salam sejahtera bagi kita semua. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, salam kebajikan. Thank you for clicking this video. My name is Stefi Samel Markus Lumi, NIM 211011105001 from Pharmacy A 2021, Faculty of Mathematics and Natural Science, from Samratulangi University. In this video, I will explain to you about heat transfer and Fourier's law. So, there are two contents that I will explain to you in this video. First, heat transfer, and the second is Fourier's law. The heat source for our planet is the sun. Energy from the sun is transferred through space and through the Earth's atmosphere to the Earth's surface. Since this energy warms the Earth's surface and atmosphere, some of it is or becomes heat energy. Heat may be transferred in three ways: by convection, conduction, or radiation. First, about radiation. If you have stood in front of a fireplace or near a campfire, you have felt the heat transfer known as radiation. The side of your body nearest the fire warms, while your other side remains unaffected by the heat. Although you are surrounded by the air has nothing to do with this transfer of heat. Heat lamps that keep food warm work in the same way. Radiation is the transfer of heat energy through space by electromagnetic radiation. Most of the electromagnetic radiations that comes to the Earth from the Sun is invisible. Only a small portion comes as visible light. Light is made of waves of different frequencies. The frequency is the number of instants that a repeated event occurs over a set time. In electromagnetic radiation, its frequency is the number of electromagnetic waves moving past a point each second. Most of the solar radiation is absorbed by the atmosphere, and much of what reaches the Earth's surface is radiated back into the atmosphere to become heat energy. Dark-colored objects such as asphalt absorb radiant energy faster than light-colored objects. However, they also radiate the energy faster than lighter-colored objects. The next way of heat to transfer is conduction. Conduction is the transfer of heat energy from one substance to another or within a substance. Have you ever left a metal spoon in a pot of soup being heated on a stove? After a short time, the handle of the spoon will become hot. This is due to transfer of heat energy from molecule to molecule or from atom to atom. Also, when objects are welded together, the metals becomes hot, or the orange-red glow, by the transfer of heat from an arc. This is called conduction and is a very effective method of heat transfer in metals. However, air conducts heat poorly. The last way of heat to transfer is convection. Convection is the movement of heat by a fluid such as water or air. The fluid, liquid or gas, moves from one location to another, transferring heat along with it. This movement of a mass of heated water or air is called a current. The transfer of heat energy in a fluid. This type of heating is most commonly seen in a kitchen with a boiling liquid. Air in the atmosphere acts as fluid. The sun radiation strikes the ground, thus warming the rocks. As the rock's temperature rises due to conduction, heat energy is released into the atmosphere, forming a bubble of air which is warmer than the surrounding air. These bubbles of air rise into the atmosphere. As it rises, the bubble cools with the heat contained in the bubble moving into the atmosphere. The next content is Fourier's law. This law was formulated by Joseph Fourier in 1822, who concluded that the heat flux resulting from thermal conduction is proportional to the magnitude of the temperature gradient and opposite to it in sign. Fourier's law states the negative gradient of temperature and the time rate of heat transfer is proportional to the area at right angles of that gradient through which the heat flows. Fourier's law is the other name of the law of heat conduction, where the equation is Q equals to minus the material conductivity and the temperature gradient. A material that readily transfers energy by conduction is a good thermal conductor and has a high value of K. Fourier's law is an expression that defines the thermal conductivity. As can be seen, to solve the Fourier's law, we have to involve the temperature difference, the geometry, and the thermal conductivity of the object. Similarly, as the Fourier's law determines the heat flux through a slab, it can also be used to determine the temperature difference when Q is known. This can be used for calculation of the temperature in the center of fuel belt as will be shown in following section. For an example, a major source of heat loss from a house is through the window. Calculate the rate of heat flux through a glass window 1.5 meters times 1.0 meters in area and 3.0 millimeter thick. If the temperature at the inner and outer surface are 14.0 Celsius and 13.0 Celsius respectively, calculate the heat flux through this window. The solution is, at this point, we know the temperatures at the surface of material. These temperatures are given also by condition inside the house and outside the house. In this case, heat flows by conduction through the glass from the higher inside temperature to the lower outside temperature. We use the Fourier's law of thermal conduction equation. We assume that the thermal conductivity of a common glass is K equals to 0.96 and the heat flux will then be Q equals to 0.96 times 1 is divided by 3.0 times 10 power by minus 3 is equals to 320 and the total heat loss through this window will be Q loss is equals to Q times A equals to 320 times 1.5 times 1.0 is equals to 480 watt. That is the explanation that I can give to you about the heat transfer and Fourier's law. I hope you can understand. And that is all for this video. Thank you for watching and see you on the next video.